Alright, so it may work best if you pause this and copy it and then listen to what I'm saying. Alright, so hopefully you've copied that down. This is topic 1 of our chapter 6, all about systems of equations. So a system of equations is when you have two equations or more that all use the same variables. The solution is the pair of numbers x and y that solves both of them at the same time. Alright, so first way we're going to do this is by graphing, and you'll see not just when graphing, but actually on all the methods, there's three possibilities. You can have one unique solution, you could have an infinite number of solutions, or no solution at all, just like when we're solving equations. Alright, so a system of equations in two variables is this. Now a line is really the collection of all the pairs of numbers that make this equation true. So it's really important to think of a line that way. So let's look at the pair of points 0, 4. Alright, so that's our x and our y. That's on our line because if we plug that in, 4 equals negative 2 times 0 plus 4. Right? That works. That's why this point is on our line. If we were to pick another point, negative 1, 6. Plug that in and we get 6 equals negative 2 times negative 1 plus 4. That's 2 plus 4. So that works. Alright, so this point is on our line. That would not work if I plugged these numbers into this equation. So all the pairs of numbers, all the x, y's, that would work if I plugged it in are represented by this first line. All the pairs of numbers that would work for this, so like say 2, 5 for instance. 2, 5 is a point on this line, and that's because it works when I plug it in. 3 times 2 minus 1, which is 6 minus 1, which gives me 5. Alright, so if I were to represent all the numbers that if I plugged them in would give me a true statement, that would be all these pairs of numbers. Right? Every point represents a pair of numbers. So all of them would be the whole line. The solution to a system of equations is that one point that works for both equations. If I plug this into here, I get 2 equals negative 2 times 1 plus 4. So 2 equals 2, works in that one. And then if I plug it into here, it works as well. 2 equals 3 times 1 minus 1, which is 3 minus 1. So it works in this one. So this is the solution to my system, because this x and this y solve this, or not solve, but work when you plug it in here, and work when I plug it in here. So it's easy to see that graphically, if we have equations with the same slope, so this has a slope of 2x and this has a slope of 2x, right? If they have the same slope, there can be no point that is on this line and on this line at the same time. There's no place that they cross, so there's no solution. If we give you two equations that end up graphing the same line, that's when there's an infinite number of solutions, because every point that's on one line is also on the other. Alright, so just based on a graph, what would the solution to this system of equations be? This is your first U-try. Nice. Alright, now to find the following solution to the following system. There's two ways you can do this. You can convert this to y equals mx plus b, so minus 2x on both sides. So I got y equals negative 2x plus 4, and that would be a y-intercept of 4, and then down 2 over 1. When you're doing this by graphing, it's a good idea to plot all the points, so continue your pattern as far down as possible. That way, if I plot a point on this blue line, and then I plot a point on this line, and they end up being plotted in the same spot, well then I know I've got my solution. Alright, the other way to graph these is to find the intercepts. So if x is 0, I cover up x, and that gives me y equals negative 2. If I cover up the y, that gives me x equals 2. Oops, there we go. So 0, negative 2 is a point on my line. 2, 0 is a point on my line. So see how I graphed the same point that already had a blue dot there? That guarantees me that it's on both lines. So there we go. That's my solution. 2, 0. So you can write it as a point, your answer like this, or you can write it as x equals 2, y equals 0. Either way works. Now every time you do this, you get to check your answer, alright? Because you can guarantee whether you've done it right or not. If I go to my equations and I plug in, remember I said my answer was 2, 0. Plug in the 2 for x and the 0 for y, works in this one. Plug it in here, works for this one. So if it was a multiple choice question, and they gave you different points, you could just plug in the x and y and see which works in both equations, and that would be your correct answer. Alright, so let's do a couple more of these. Negative 3 is my y-intercept, and then I'm going to go up 2 over 1 because that's my slope here, 2 over 1. Continue the pattern so that I know when they intersect. My line's not great, but we're going to make these come out to whole numbers. They don't have to, but these ones will. So cover up the x, gives me y equals 1. Cover up the y, and x equals 1/2, or negative 1/2. So if I don't like the idea of trying to plot negative 1/2, 0, what I can do instead, and then a 0, 1, what I can do instead is just get it into slope-intercept form. So I can add 2x to both sides, and I get y equals 2x plus 1. Then it becomes very obvious that because they're parallel, there's no solution, and also I see that I have the same slope here. 2 and 2 is my slope, so there can't be any solution. So the final answer for this is no solution. Alright, so one more. Y-intercept is positive 3. Whoops. And then down 2, forward 1, down 2, forward 1. And then I'm going to do the intercepts for this. So this is actually for this equation. So cover up x. Negative 4y equals 8, so y is negative 2. Oh, come on. And then cover up the y. So x is 4. 4, 0. And 0, negative 2. Alright, so it looks like they hit right here. Let me double check. This goes up 2 over 4. So my slope of this line is 2 over 4, which is the same as 1/2. So up 2 over, or up 1 over 2, up 1 over 2. So yep, this point's definitely on my line. So here's our solution. 2, negative 1. Alright, and then I should plug those in and check, which I didn't already do. So here we go. 2 times 2 minus 4 times negative 1 equals 4 minus, minus times minus is plus, 4 equals 8. So it works in the first one. Negative 1 equals negative 2 times 2 plus 3, which is negative 4 plus 3. And it works in the second one. Alright, so that's definitely the correct answer. Make sure you check your answers every time. So I believe this is blank on yours, and what you should do is pause this, copy it down, and this is your steps. So you graph both, either using the slope and y-intercept or the intercepts. And then where they intersect, that's a solution. Make sure you label it. And then make sure you always check your answer. Here's your U-try, and I'll see you next class.